Although the James Webb Space Telescope has only been operational for 2 years, it has already made a significant impact on the world of astronomical research. But how do we explain the first standard discoveries made by Webb that completely challenge our current theories? And what about the baffling deviation in the rate of cosmic expansion, which has long left researchers puzzled? Well, perhaps these impossible discoveries are the result of a combination with other universes, a concept that may sound like the plot of a quirky sci-fi movie, but which is actually at the heart of an official scientific study published recently and could lead us to an incredible discovery. The view of the starry sky at night is simply breathtaking, and yet in the same breath, it raises a basic but profound question. Where does it all come from? In other words, how did the universe and its vast diversity come into existence? While the inhabitants of ancient civilizations mainly referred to divine creators in this regard, modern scientists take a slightly different approach, considering other worlds and measuring distances. Specialists have mapped out a conclusive picture of the birth and development of the universe over the last few decades, and according to the standard cosmological model, it began around 13.8 billion years ago when space, time, and matter emerged from an incredibly dense and hot singularity. In detail, however, the Big Bang did not only open the way for the expansion of the universe, it also triggered a process that continues today, the cosmic expansion. To explain the observed accelerated expansion of the universe, the mysterious dark energy has once again been invoked, although its presence has not been directly proven experimentally, and its interpretation remains largely unexplained. Yet our understanding of the universe is now more precise and complete than ever. But what if that is not simply true? What if our fundamental cosmological assumptions are no longer viable due to new discoveries? This is precisely the question that astronomers are inevitably faced with at this moment. As you have undoubtedly noticed, the James Webb Space Telescope has already detected several structures that, according to our theories, should not exist in this form. This concerns, in particular, the so-called impossible systems that formed in the early universe, which throw our models into chaos with their surprisingly large mass. Webb has identified 6 galactic precursors, whose light took more than 13 billion years to reach our eyes on Earth, and which, despite this, were almost as developed as our Milky Way today. According to our understanding, there simply wasn't enough normal matter to support such massive structures so soon after the Big Bang. This unexpected discovery challenges our entire picture of the early universe's structure. But the next discovery shows that this is by no means an isolated and baffling case. With JWST 14-0, Webb added another early galaxy to the scene of stars that already existed 290 million years after the Big Bang. However, the Space Telescope not only provided scientists with a new record-breaking galaxy, but also another distressing puzzle. The analysis by specialists revealed that JWST 14-0 already contains several hundreds of millions of solar masses of stars. Additionally, the presence of oxygen in the emissions suggests that several generations of very massive stars must have gone through their life cycle before researchers observed the galaxy. In light of these elements, the current image of a primitive universe containing only small, faint galaxies seems outdated. But in truth, these so-called universe breakers are far from being the only cosmic curiosities that Webb has delivered. In fact, the most powerful space telescope of all time has also confirmed a number of unexplained discrepancies in the Hubble constant, which have been giving scientists headaches for years. Specifically, the mystery of cosmic expansion. If anyone knows about the expansion of the universe, it's Adam Rees. After all, the American astrophysicist won the Nobel Prize in Physics in 2011 with Saul Perlmutter and Brian P. Schmidt for the discovery of the accelerated expansion. However, the famous researcher could possibly be quoted in relation to his latest research. There is a real and exciting possibility that we have misunderstood something fundamental. To understand the significance of this profound statement, we must keep in mind that, contrary to expectations, the expansion of the universe is not uniform everywhere. In fact, the universe appears to be expanding more rapidly in our cosmic neighborhood than in other parts of space, which, strictly speaking, should not be the case. The driving force behind the accelerated expansion of the universe is dark energy, which is supposed to counteract gravitational attraction. The current rate of expansion of the universe is indicated by the Hubble constant, a parameter in Einstein's field equations that describes the rate of expansion. Adam Riess explains that his colleagues, and he can predict the rate of expansion by measuring the cosmic microwave background radiation and then using theoretical models of cosmic development to determine the current rate of expansion. This results in a Hubble constant of 67 kilometers per second per megaparsec. However, the situation becomes extremely confusing at this point. If we now use another method of measurement, the value of the Hubble constant suddenly becomes completely different. In other words, if we determine the constant based on supernovae, red giant stars, gravitational lenses, and Cepheid variable stars, we get a result of 73 kilometers per second per megaparsec. In other words, the universe is expanding faster than it should be. But how is this conceivable? Well, the simplest explanation lies in the assumption that the discrepancies are the result of a combination of measurement errors and inaccuracies. To verify this hypothesis, Riess' team used Webb's near-infrared camera and IRCam, which then closely examined more than 320 Cepheids in several galaxies. Since many of these stars had already been targeted by the Hubble Space Telescope, this re-examination allowed for a comparison. It ultimately revealed that Webb's data was correct. This means that Webb's new data also provides a Hubble constant that exceeds theoretical models by a significant margin. But why is this the case? What is behind Adam Riess' statement that we may have misunderstood the universe? Well, in detail, the Nobel laureate suggests that there might be a process or force behind the rapid expansion of the universe that has not yet been taken into account in the standard cosmological model. It could be some exotic form of dark energy or dark matter. It may also be that our understanding of gravity is wrong, or that there are new particles or fields that are completely unknown to us. The theory of combining universes also accounts for these discrepancies. For example, the hypothesis of intelligent design holds that certain features of the universe are better explained by a conscious cause. This group of scientists is thus open to the possibility of a creator. However, the definition is not precise. It's not about the idea of a god, but rather the scientific examination of the thesis that the complexity and order of the universe indicate an originating and superior plan. Another hypothesis presented in the Journal of Cosmology and Astroparticle Physics is as exciting as it is unorthodox. The reason for the deviation in the Hubble constant could be that our universe is merging with other universes. This approach moves away from the idea of the troubling dark energy, which could plausibly account for the expansion of the universe on paper but whose actual existence has not been proven as mentioned. And when the merger of cosmic worlds is considered more likely, physicist Jan Amborn of the University of Copenhagen emphasizes that a model based on merging with what are called baby universes could explain the data collected much better than the standard cosmological model. The study's lead author and team have developed a mathematical model to study the hypothetical effects that merging universes could have on our cosmic home. Their calculations showed that merging with other universes should increase the volume of our universe, an effect that could be perceived by our measurement instruments as an expansion of space. Subsequently, the standard cosmological model traditionally also addresses the problem of cosmic expansion. This refers to the stage of extremely rapid expansion of the universe, which is believed to have occurred shortly after the Big Bang. Until now, physicists have suggested that this rapid expansion was caused by the inflaton, a hypothetical field that drove the ultra-fast expansion in the first milliseconds after the enormous detonation. However, the authors of the new study now explain cosmological inflation by suggesting that our young universe may have been absorbed by a parent universe, and that our world subsequently followed the path of its mother. Scientists suspect that our universe continued to interact with other baby universes after its formation, and even absorbed them during their journey. But how could this exciting theory be tested? Would it even be conceivable to directly observe the baby universes that our ever-growing world is absorbing? Well, it's not entirely clear. Specialists are currently focusing on the cosmic radiation. This almost isotropic radiation that fills the universe and was created shortly after the Big Bang. It may have unexplored properties that could lead us to a revolutionary discovery in the near future. We would be thrilled if your near future leads you straight to the subscription button. Don't hesitate to hit the like button and subscribe so you never miss another exciting video from us.